In this video, I will talk about trigonometric substitution in calculus, how to calculate the integral, okay? So for example, you have the integral look like this. So like a square root of a squared minus x squared, dx, right? So the only way to do it is to trig substitution. So if you meet the integral like that, you're gonna let x equal to a sine of theta, all right? So if another case, if you have the integral is a squared plus x squared dx, right? We're gonna let x equal a tangent of theta, okay? And if we have the integral which is x squared minus a squared dx, our substitution gonna be x equal a secant theta. Okay, so this is the general tips how to deal with trigonometric substitution. Okay. Okay, let's move on to the first example. We have the integral for 25 plus x squared dx, right? So this is the integral and how we like evaluate it. Okay, so you know that this integral is a squared plus x squared, right? Where a is 5, right? So as I mentioned before, if you meet the integral like that, we're gonna let x equal to a tangent of the angle, right? So a is 5 tangent of the angle. So we're gonna let x equal to 5 tangent of that, right? So next one, I'm gonna differentiate both sides. So I'm gonna have the x equal 5 secant square theta d theta, because derivative of tangent square, or derivative of tangent is secant square, right? So next one, we gonna substitute x back to this integral. So we're gonna have 25, x is 5 tangent theta, right? So it's gonna be 25 tangent square theta, right? And what is the x? So the x is right here. The x is 5 secant square theta d theta, right? So next one, this equal to, 25 is a common factor, right? So I'm gonna factor 25 out, and because of the square root, so square root of 25 is gonna be 5, right? Square root of 1 plus tangent square theta, 5 secant square theta, right? D theta. And this one equal to, as the trigonometric identity, square root of 1 plus tangent square is secant, right? This is secant. And this is 5 secant square theta d theta, right? So this is equal to 25 the integral of secant cube theta d theta, right? So next one, I'm gonna use the quick formula to do the integral of secant cube. So you know that it's a common formula, so you can search for it. So secant, the integral of secant cube theta equal to 1/2 natural log of secant theta plus tangent theta, right? Plus secant theta multiply tangent theta and parentheses. Okay, so we have, so this one is not parentheses, right? So secant multiply tangent is inside the parentheses. Okay, so now we have the integral going to be 25, sorry, the integral going to be 25, the integral of secant cube, right? So this is equal to secant, the integral of secant cube equal to this one. So it's supposed to be 25 over 2 on natural log of secant theta plus tangent theta and plus secant theta tangent theta, right? So next one, we have to convert theta back to x, right? So we know that x equal to 5 tangent of theta, right? So tangent of theta equal to x over 5, right? So tangent theta equal to x over 5, so I'm gonna draw a triangle. So if we have a triangle look like this, and this angle is theta, right? So we have tangent theta equal to x over 5, right? You know tangent equal to opposite, right? Over adjacent, right? So the opposite side of the angle gonna be x, right? And the adjacent side gonna be 5. So this is 5, right? So based on the triangle, we're gonna find secant and tangent, right? So you know that secant of theta equal to the hypotenuse, right? Over the hypotenuse over the adjacent, right? So it's equal to, you know, the hypotenuse using the Pythagorean theorem is going to be 25 plus x squared, right? So the hypotenuse is going to be 25 plus x squared. And adjacent is 5, right? So this is secant. And now we finished calculating secant, right? Next one, we're going to calculate tangent. So tangent of theta is x over 5, right? So we already given, so that is given, right? So we calculate tangent of theta. Next one, we're gonna substitute secant and tangent back to the result of the integral. So 25 over 2, right? Natural log of secant theta, right? Secant theta is this one, right? And tangent theta, secant theta is 25 plus x squared over 5, right? And tangent theta gonna be x plus 5, right? Plus secant theta is 25 plus x squared over 5. Multiply, right? So multiply x over 5. So x over 5, 5 multiply 5 is gonna be 25, right? And plus c, right? The parenthesis right here. And sorry, I forgot plus c right here, okay? So this is the final result. Okay. Okay, we're gonna go to the next example. So, for example, we have the integral of x over x squared plus 4 dx, right? So how we solve it? So you see at the bottom we have square root of x squared plus 4, right? So the square root of x squared plus 4, which means a is square root of 4, right? So a gonna be 2, right? So our substitution gonna be x equal to a tangent theta, right? So we're gonna differentiate both sides. So we're gonna have dx equal to secant square theta d theta. All right, next one we're gonna substitute x back into the integral. Okay, so we're gonna have, you know, x at the top we have x, right? So x is 2 tangent of theta, right? And the bottom is x squared plus 4, right? So we substitute x in, we're gonna have 4 tangent square theta, right? Plus 4. And the x gonna be 2 secant square theta d theta, right? So this is equal to 2 tangent theta, right? And the bottom, number 4 is common factor, right? So I'm gonna factor 4 out, and I'm gonna have 2, right? And tangent square plus 1 is gonna be secant square, and our square root is secant, right? So rewrote the remaining. So we're gonna have secant cancel secant and 2 cancel 2. Secant cancel 1 secant. So we're gonna have the integral tangent theta secant theta and number 2. Okay. Next one, I gonna break tangent and secant down to sine cosine. Okay. So you know tangent equals sine and over cosine, right? And secant equal 1 over cosine. So that essentially sine over cosine square, right? And the next one, if I want to evaluate this integral, I have to use substitution, right? Because I noticed that if I let u equal to cosine of theta, right? I'm going to have the derivative of u du equal to minus sine theta d theta, right? So I noticed that if I plug in u to back to this integral, I'm going to have the integral gonna be 2. Okay, so you know sine of theta d theta is negative du, right? So this is negative du, and cosine gonna be u square, right? Cosine square is gonna be u square, right? So this equal to the integral of negative 1 over u square gonna be 2 1 over u, right? 1 over u, right, is the result of the integral negative 1 over u square, right? And plus c, right? So that's equal to 2 over u plus c. Okay. So first, I need to convert u back to x, right? So I know that u equal to cosine of theta because of this one, right? So plus u, right? Okay. So I have to convert cosine of theta back to x, right? So you know that at first I let x equal to 2 tangent of theta, right? So if I draw the triangle, so from here I'm gonna have tangent of theta equal to x over 2, right? So this is theta, right? Tangent is opposite over adjacent, sorry. Opposite over adjacent, right? So this is x, this is 2. And the hypotenuse is gonna be 4 plus x squared, right? So what is cosine of theta based on the triangle? Cosine of theta gonna be adjacent of the angle is 2, right? 2 over the hypotenuse is gonna be 4 plus x squared. Okay. So I know that cosine of theta equal to a function in terms of x, right? I'm gonna plug in cosine of theta back to the integral. Okay. So cosine of theta gonna be 2 over 4 plus x squared, right? Plus c, right? So 2 gonna cancel 2. And this fraction gonna be flipped over. So that is 4 plus x squared plus c. Okay. So this is the final answer. Alright. If this video is helpful, don't forget to like and subscribe for my channel. Thank you so much.